There's also another way to get all the trig functions of an angle given one of them. If you're given something like this, that cosine theta is 5/7, we know that cosine is adjacent over hypotenuse. So we can draw a triangle. Doesn't have to be to scale. Say that this is our angle, and if our cosine is 5/7 adjacent, we can say label with 5, and the hypotenuse we can label as 7. And then we can figure out our third side using Pythagorean theorem. It'll be square root of 7 squared, which is 49, minus 5 squared, which is 25. So this side then is root 24, which is 2 root 6. And we can figure out our 6 trig functions that way. So sine theta is opposite 2 root 6 over hypotenuse, 7. We already have cosine theta. Tangent is opposite over adjacent, so that is 2 root 6 over 5. We can find the other 3 trig functions just by taking reciprocals. Sine of theta is 2 root 6 over 7, therefore cosecant theta is 7 over 2 root 6, which rationalizes to 7 root 6 over 12. Secant theta is the reciprocal of cosine, so it's just 7 over 5. And cotangent of theta is the reciprocal of tangent, so it is 5 over 2 root 6, which rationalizes to 5 root 6 over 12. And there we've got all 6 of our trig functions. Now, this is probably somewhat easier than using the trigonometric identities, but we want to be able to use the trig identities algebraically, and we'll be doing a lot of that. We'll be doing some of that this chapter and doing a lot of it next chapter. So you need to be able to use both methods. And on a test or quiz, I will specify which one I want you to use. And if the directions say to use a particular method, then you need to use that method. Our trig functions can also allow us to find the missing pieces of a triangle. Now these drawings aren't necessarily to scale, but if we're given that this angle is 35 degrees and this side is 4 inches, this is a right angle, then we can find all the missing pieces of this triangle. The angle is really simple. This is 90 degrees. We know that the angles of a triangle add up to 180, so these two have to add up to 90, so we can figure out pretty easily that that angle is 55 degrees. Then we can use trig functions to figure out the rest of our sides. We've got this angle, we've got the angle, and we've got the opposite side. So we can use sine to figure out the hypotenuse, because sine is opposite over hypotenuse. So that's 4 over the hypotenuse, which we can rearrange, figure out that our hypotenuse is 4 over sine of 35 degrees. Now 35 degrees isn't one of our special angles, so that one you'd have to punch into your calculator in order to solve. Now, if you press the mode button, one of the modes on your calculator, it says radian and degree. And as you might guess, radian means it's a radian angle and degree means it's a degree angle. So whenever you're doing something you need to punch in your calculator, you need to make sure you're in the correct mode, or else you won't get the right answer. So if I punch in 4 over sine 35, I'm in degree mode. That comes out to be about 6.97 inches. If a problem gives you units, make sure you include units in your answer. And we're going to stick to our standard of rounding to hundredths whenever necessary. We can then find this missing side. That's the adjacent side. So if we take the tangent of our angle, that's equal to opposite, which is 4 inches, over adjacent, which is what we're trying to figure out. So then that adjacent side is equal to 4 over tangent of 35, which we can punch into the calculator to get that that side is about 5.71 inches. Right. Just another example really quickly. We're given that the hypotenuse is 15 centimeters, this angle is 71 degrees, then the sine of 71 degrees is equal to this opposite side over the hypotenuse, 15. So that opposite side is equal to 15 times the sine of 71, which again we can punch in 15 sine 71. That's 14.18. centimeters. And the adjacent side, in like manner, if we take the cosine of 71, that's equal to the adjacent side over 15. So that adjacent side is 15 times cosine of 71, which we can plug in to get 4.88 centimeters. So if we're given an angle and one side of a right triangle, then we can figure out all the other pieces by using our trig functions. Now, I could also give you, most of these problems will be word problem types where you'll have to read whatever information it gives you and kind of draw the picture on your own. But the principle is the same as what's going on right here.